storage tiering, snapshots, and replication. These are three more advanced features on storage. And the idea behind these kind of sounds like pixie dust. It sounds like it's impossible. What if your backups took just 10 seconds? What if the SAN automatically put frequently accessed stuff on the fast storage and put rarely accessed stuff on slow storage? Everything that's in here is doable, but I want to explain it in a sense that SQL Server people are going to understand. You don't have to know how to configure these things, but knowing how they work internally will change how you work with SQL Server when it's time to use these features. They're not right for everyone, but when they are right for you, I want you to be able to recognize this is the feature that I need, ask your SAN admin for it, and what you need to do differently in terms of SQL Server, because you do have to change what you do when you use these features. I'm going to start with tiering. In order to explain tiering, I'm going to use a really simple table. I'm going to say that I have a bloggers table in SQL Server. It only has 2 fields in it. It's got the list of a bunch of bloggers in the SQL Server community, all the way from Mr. Adams down to Mr. Van Dyke, who recently got hired by Microsoft and stopped blogging, as is the case with everyone who goes to work for Microsoft. I'm always happy when my friends go to Microsoft because it's a cool company and it's a lot of fun to work there. But they disappear. They stop talking to anyone in the public because they know everything that's NDA. And it has the last time that they updated their blog. To keep it simple, we had a blog party at 1 a.m. and everyone was invited. Now, the way that you usually lay this stuff out on disk is by striping it across lots of different hard drives. Say that I have 4 hard drives up, and you can see me taking a picture there of my open hard drive in the reflection of the hard drive platter. I never noticed that before. So drive 1, drive 2, drive 3, and drive 4, you would lay your data out striped across all of these drives so that when you need to read, it's 4 times faster because all of these drives can start yelling results back to the SQL Server. Granted, the SAN is what controls, or the storage processor or filer controls that the data comes back in the right order, but we're able to satisfy a whole lot more requests or a whole lot more input-output operations per second, IOPS, the more drives that we have. Now, you would never actually configure a SQL Server the way it's shown here on the screen, because if I lose any of these drives, I'm hosed. If I lost drive 3, I wouldn't know anything about Denny Cherry anymore or Michelle Ufford. So what you would normally do in real life is you would have multiple copies of your data. This is what we call RAID 10 or RAID 0+1 or 1+0, depending on your vendor's implementation. That I would have Mr. Adams, Mr. Bertrand, Mr. Cherry, Mr. Dawei on 2 separate sets of drives. That's absolutely correct. It's just that I have a limited amount of space here on the screen to show you stuff. So for the rest of this session, I'm going to pretend like we're only using 1 copy, the copy on drive A. Just know that in real life, there would be more redundancy involved. I'm just trying to keep it simple for limited amount of screen space. The old way that we would configure our storage is we would have SQL Server with its own dedicated drives just for SQL Server. We would have a separate set of drives just for Exchange. We would have a separate set of drives just for our file server. And database administrators like this because they would say, no one else can slow me down. I know that my stuff is always going to be the same speed. Except the thing was, it was just predictably slow. It was always slow. It was never fast enough. Because I would never budget enough drives for a SQL Server. And sometimes I would budget too many drives for the wrong SQL Server. I'd have too many drives on this server over here, especially as it got old and deprecated, and then I'd have less drives for the brand new servers that I just built that we were going into production. So we lost that war. This isn't how you configure storage anymore. When you're dealing with shared storage, you have a big pool of drives, and your data is intermingled across all of them. What other people do on their drives, yes, does impact performance. But I like to call this unpredictably fast. Because sometimes when no one else is using it, it's actually way quicker than it ever was before. And most of the time, it's still kind of slow. But my data's striped out here across drive 1, 2, 3, 4, 5, 6, 7, 8. And something has to maintain a map of where all my data lives. That something is the SAN. The storage processor or filer maintains this map of where, say, Mr. Bertrand lives. If we need to access Mr. Bertrand, we know that he lives at slot 2A. If we need to access Lori Edwards, she lives at slot 1B. Now, if the SAN is tracking where all my data lives, and it lives on different drives, there's no reason that I couldn't put some of my data on fast drives like solid state and some of my data on slower drives for people who don't update their blogs very often. Your storage doesn't have to know how SQL Server works. Your storage doesn't have to understand where a record is, where a page is, how extents work. The storage just looks at which data do you access a lot, which data do you not access a lot, which data do you change a lot, and which data never changes. And then, based on your change rate, it automatically puts frequently accessed, or what I would call hot data, on faster drives, and puts older, slower, less accessed data on older, cheaper, slower drives. Now, the exact implementation of how this is done is different on a vendor-by-vendor basis. Some of them move a whole volume, like what you might call a drive letter or a mount point, may move the whole volume from one tier to another. All of this is done in real time without you knowing about it. Just as the storage is bored, it counts up how many times you access various parts of drives and moves the drives around based on demand. Another way to do it is block level tiering, where inside one volume, if you look at the M drive, for example, some parts of it will be on fast storage and some parts of it will be on slow storage. This usually scares the bejesus out of DBAs, but look, here's the deal. It's just that some of your data will be unpredictably fast, and in a perfect world, it's the data that you access a lot. Think about a data warehouse. In a data warehouse, you're always loading current data, and then you turn around and query last night's data. You're not querying 6 Thursdays ago. Wouldn't it be nice if the data from 6 Thursdays ago dropped down to slower storage when we accessed it less often? It wouldn't matter what version of SQL Server you're on, what edition of SQL Server you're on, whether or not you could change the application. This is so awesome because you don't have to do things like partitioning or do fancy pants indexing, file groups, any of that. The SAN is just smart enough to figure out which data belongs on which tier. Now, depending on what kind of which vendor you have, this determines the exact implementation. For example, with EMC, you get to pick what percentage of a given LUN lives on solid state. With Dell Compellent, every write starts out on the fastest tier and then gradually ages down as that data is read less and less often. NetApp only uses the solid state for caching. So they have this fast cache stuff where it's used to satisfy reads, it's just not used at all for writes. Everything you're going to have to go check is what kind of vendor you have for your storage, and then that tells you how it's implemented. You don't need to know, you just need to know whether you need tiering or not. And the classic example is data warehouses, especially stuff that's not partitioned, where I always want the new data on the fastest drives. This stuff even helps you when you start to replace your storage. So say that out of our SQL Server data map, I've got a couple of Dell EqualLogic units here. These are just pizza boxes loaded with hard drives. And say that these are getting old. They're like 3, 4, 5 years old, and we want to replace them. Normally, replacing storage sucks. It's all kinds of work. I got to take an outage window with SQL Server. I got to log ship things from one place to another. But with tiering, especially automated tiering with my SAN, it can add in a brand new hotness pair of units. Maybe these are loaded with more drives or with solid state. It can evict the old units, copy all of the data out, move them, get them in sync first with the newer units, then gradually just stop making any writes to the top units, and then get those guys out of our data center. That's really cool in one sense, because once I implement a SQL Server, remember I said that I want to, whenever I build a brand new SQL Server, I want to leave it in place for as many years as possible. This lets me pull that off for even more years than I would have been able to do before. However, I may have some problems with, I get someone says, oh no, okay. However, it doesn't automatically give me unlimited amount of fast storage. When I say this to DBAs, they often go, great, I want to put all my data on the fast tier. Well, yeah, but you didn't buy unlimited solid state storage space. You want to be able to tell your SAN admin, all right, this one is one that needs to be on a mix of fast and slow storage. This SQL Server could all be on slow storage, giving them that flexibility of putting some with solid state and some on less solid state helps them mix and match this stuff better. When I decide to pull the tiering trigger, if I have this feature available to me and I want my SAN admin to turn it on, I want to do less index maintenance. Because index maintenance is effectively writing to blocks, moving them around, making them look like they're more frequently accessed when maybe they're not. I got to make sure to use smart index rebuild scripts and only touch tables that are actually changing. I may even want to exclude some tables from any index maintenance at all. Say, for example, you have a logging table where people just dump data in all the time. Who cares? Just let them dump data in. You're not going to do anything about it. You're not going to go rebuild the indexes because I don't want to worry about that jumping up to a really fast, super high premium speed of storage. Hold on a second here. A student's got a question. Martha, it looks like you have two windows open or you have two WebExes open or GoToWebinars. If you can close one of those, that'd be great. I just want to make sure that we don't have somebody else stealing your login there. So that's automated tiering, where the SAN automatically puts faster or more needy data over on solid state. The next feature is called snapshots. Now let's go back to having our map again. Say that we got our map of bloggers, and the SAN is keeping track of where all of our data lives, where Brent's data is, where Denny's data is, where Aaron Bertrand's data is. Now let's focus on Aaron Bertrand for a second. Aaron Bertrand is at slot 2A, and Microsoft brings out a new cumulative update or service pack, which is one of Aaron's favorite blog topics. And as soon as they bring it out, Aaron wants to write a new blog post. So we need to run an update statement. We want to run an update to set Aaron's blog to updated as of 9 a.m. Now, there's two ways that I could do this. One way would be for me to write right over where Aaron's old data was. And this is what we think of writes as being inside SQL Server, that we're going to write over the exact same location. And that is what SQL Server does internally. But what the SAN could do is the SAN could write Aaron's data to a new location. Every time that we change something in storage, we could actually write that version, the newer version, to a different place. Now, the SAN isn't tracking rows in a table. What the SAN is tracking is changes to blocks or areas of the storage and say, oh, this area of the storage just changed. I'm going to go write that change to a new place instead of over the old place. And then what we could do is we could have a snapshot as of this morning. I could have one map of where all my data lived, and it would include Aaron pointing in slot 2A, but I could have a current map showing where everyone's data lives right now, and when Aaron goes to write his new blog post, I would say that he lives in a new location. So now I have one map showing where everyone was an hour ago, and then another map showing where they are right now. I kind of have a backup of my data and a current copy of my data without taking twice as much space. Snapshots are copies of the map of where our data is. I can take a snapshot of the map, and then every single time I write new data, I just write it to a different place. I need enough space to handle my change rates, but I don't need a whole copy of all of the data. Think about, say you have a 1 terabyte database. All 1 terabyte of it doesn't change every day. You have a change rate, but it's not 100% every single day. Snapshots are a way of getting a backup of your database, kind of. I'm going to talk about why it's not exactly a backup here in a minute. There's 2 ways to take a snapshot. One way, crash consistent, is when the SAN simply takes a copy of the map without telling SQL Server. When you go to attach that map, it's just like you attached a copy of a drive or a set of drives when SQL Server might have been in the middle of doing things. So it's exactly like getting a picture of your drives at the moment in time when someone yanked the cords out of the back of your SQL Server. SQL Server's remarkably good at coming up in those scenarios. It's pretty good at recovering from mid-flight crashes, but it ain't perfect. And a lot of people will test these, the dirty snapshots, aka crash consistent. They'll test them a few times and go, wow, it works just fine. And then when the emergency hits and they need to jump back to that snapshot, it does not work fine. They go to attach it and the databases are corrupt. So database administrators, we don't like gambling like that. I love gambling, just not with my databases. So what you'll see with SQL servers is people use application-aware snapshots. This is where there's a driver involved. The driver works in cahoots with the SAN to say, all right, Windows, I need you to freeze all writes to a particular volume or drive letter or mount point. Windows sends out this notification to all running applications, including SQL Server. SQL Server hears this and freezes, cleans up its writes and says, okay, you're good to go. I've done kind of a graceful stopping of writes. If I attach this database now, it'll look nice and clean and I'll be able to recover. Storage takes a copy of the map, then tells Windows and SQL Server, you're good to go. This does introduce blocking. Because what happens is SQL Server has to finish up its writes and then wait for the SAN to do its thing. In a perfectly configured environment, you're talking about 1 to 5, maybe 10 seconds worth of waiting for this process to complete. In a poorly configured environment, it can be 30 or even 60 seconds of no writes on the SQL Server. So what that looks like, if you run something like spblitz-who to see what's happening on the SQL Server right now, you'll see big, long blocking chains of lots of people being blocked by what looks like a backup. So you do have to be careful with this in terms of performance tuning it, testing the daylights out of it, making sure that it's fast. And even if you do tune the daylights out of it, people don't usually want to take snapshots every 10 minutes or 15 minutes because you don't want to deal with blocking for 5 seconds straight every 10 minutes. But if it's performed or if it's tuned perfectly, it only takes 1 to 5 seconds, then it's kind of like getting a backup of a ginormous database in less than 5 seconds. That's pretty awesome. That's pretty quick, especially in terms of multi-terabyte databases. Now, the maps are really tiny. Think megabytes, not gigabytes. But they don't even need to take much space initially at all, because all I have to do is say, all right, I've got a picture of it, and then every time someone updates their blog, I could just write what their old location was. This is called copy on write snapshots. So it can start at really tiny volumes in terms of sizes. But over time, no matter how you configure your snapshots, the more data that you change, the more space you'll need for your snapshots. This is again why, if you choose to use this feature, you ease up on the index rebuilds. Index rebuilds are essentially shuffling your data around, producing change rates. And now I'm not just worried about my transaction log volume, I'm also worried about my data size, my data volume size. To do a restore, all I have to do is switch maps. I can just shut down my primary SQL server or detach all my databases, detach that LUN, and attach the older snapshot. Presto, I'm off to the races. With tuning and work, you can get restores down to 60 seconds or less, regardless of the size of the database. Now to do this, if this sounds like it's interesting to you, what this is really for is large databases where it's hard to get traditional backups. Traditional native backups are wonderful. I love them dearly. They're always my first go-to. But it's harder to do that based on your RPO and RTO. If someone gives you a 1 terabyte database and says you have to be able to recover from oops deletes in a matter of 1 hour, then it may be hard to do a point-in-time restore. These things will also work depending on the version or depending on the vendor with log backups too. FYI, a SAN snapshot isn't really a backup, just like RAID isn't really a backup. As long as it's still inside the same SAN, there is still a ton of risk for me. Because I've had a lot of stories where people applied firmware upgrades to their SAN and trashed the whole SAN. Same thing with database corruption. If I take a snapshot of a corrupt database, my snapshot is correct as well. I really need to rely on a combination of real backups getting off of the SAN and running regular CheckDB to make sure that my data is clean. So let's talk about the next feature. We covered snapshots and tiering. The next feature, let's say that we have these two maps. I got my map as of 8 a.m., and then I got another map that's my data as of a current point in time. Who manages these maps? Well, the thing that manages the map is our storage processor or filer or controller, depending on what your make and model, what your vendor likes to call these things. In this screenshot, I'm using a picture of a NetApp, but the same thing works with EMC, Hitachi, Dell, Equalogic, Compellent, whoever. I've got my SQL Server hooked up to my shared storage, and the shared storage manages where all my data lives, what parts of it live on these hard drives, and these hard drives. Well, that's my current live map, but I also have my map that was a backup as of, say, 8 a.m. There's no reason I couldn't attach another SQL Server to that 8 a.m. map. Now, yes, they are the same set of hard drives, and if production is absolutely hammering my hard drives, then this guy's access will be slow. What if you have, say, a reporting server that just wants to read a read-only database? I could take a big, say, 10 terabyte database, take a snapshot of it, present the snapshot to another SQL server, and he could read those same volumes in a read-only way, or even be writable. I could attach this map and let the SAN make changes to it, as long as it understands that every change needs to go to a new portion of storage. They could both start writing at the same time. I could have my current snapshot that's of my production SQL servers, and then my development snapshot. And as my developers start to change things about the data, those changes go to even in different places. This is so fantastic on multi-terabyte databases where it's hard for me to refresh development. Everybody wants a copy of production and they want it as quickly as possible, but it takes forever for me to restore a multi-terabyte database into development, and then it takes multiple terabytes of space. What if instead I just take a snapshot, give it to the developers, and let them start banging away at it? They could test schema upgrades. I can test CheckDB. I can even test new versions of SQL Server. I can install a new version of SQL Server, attach it to the snapshot, and see how my queries perform, or change SPconfigure or MaxDOP settings. Now, these have a lot of limitations. Snapshots, not just writable snapshots, but any kind of snapshots. The biggest challenge that you run into is that SQL Server has to freeze I/O on all of the databases on that volume. And what's worse is it freezes them one at a time in order. So say I've got 20 databases on a volume. I have to freeze the first database, second database, third database. After I get all the way through the last one, then SQL Server says to the OS, okay, you're good to go. And then when the snapshot finishes, SQL Server thaws I/O, lets it start writing again on the 20th database, 19th, 18th, 17th. So as a result, those poor first databases can really run into trouble when we're talking about long snapshot times. Microsoft's KB articles on VSS snapshots recommend that you not snap more than 35 databases at the same time. If you're going to have more than 35 databases, they need to be on separate volumes and then snapshot those independently. Fred says, how do you recommend handling multiple SQL servers using copies of the same database, but the servers aren't on the same SAN? Can you use this SAN snapshot? Nope, this is only for the shared storage stuff. If you have different storage, you're not going to be able to use the SAN snapshots. Next up is virtualization, or last up, I suppose. So say that I've got my production SQL server and it's living on the SAN in a physical environment. With a physical SQL server, this is fairly straightforward. The physical server sees its drives directly through the storage devices. Under virtualization, though, my whole VM usually lives on the SAN, including the C drive, where my temp DB is, where my OS is, where my swap file, everything lives out on the SAN. My virtual SQL server lives in VMware Hyper-V, and VMware Hyper-V controls where my storage lives. Well, this same snapshot technology that shared storage uses, virtualization can also use. Virtualization can also take snapshots and start writing my storage to different places at the same time. So when I've got my 10-year-old storage that I'm really ashamed of, and it's a piece of junk and it's coming off lease, I can go buy my brand new all solid state storage, and this VMware and Hyper-V layer will automatically manage keeping these two guys in sync and then gradually cutting over just to my brand new storage. VMware calls this storage vMotion. Hyper-V calls this storage live migration, where I can actually move my database servers in real time from one piece of storage to another, even from one data center to another. Now, in VMware, storage DRS will even load balance my storage so that if some of my drives get too hot, it'll start moving my SQL servers, or some of them, over to other drives. This is magical. I'm just going to leave it to my VM sysadmins. I want to know when this stuff is in play because, again, I'm going to ease up on index rebuilds if it's not really fixing anything in terms of performance. You also have the capability to replicate your storage from one place to another. Your VM sysadmin can copy your data from one data center to another. This gets a little bit tricky when we start to think about databases with a high rate of change. Think about, for example, TempDB. TempDB I lovingly call SQL Server's public toilet, but we're writing over it again and again, and it's garbage data. I don't care if we keep it or not. Unfortunately, I don't get the ability to exclude certain drives or certain files when I move a VM from one place to another. VMware Hyper-V is just going to move everything from one place to another and keep them both in sync. So we covered a lot of stuff here. The next steps you have is you first ask, what make and model of storage do I have? And do we have any of these advanced features? Tiering, automated tiering, snapshots, storage replication, storage live migration. And then look at the existing SQL servers you have and see, do you have any bottlenecks that storage would fix, especially like storage tiering? If so, then you start looking at this laundry list of features to figure out which features map best to your SQL server. I can't go into the specifics of how you implement each of these across each vendor. To give you a rough idea, I did a NetApp snapshot project a while back, and it took us 3 weeks of work to get snapshots up and running and working properly for one particular data warehouse. Best practices change across all these all the time from one vendor to another. You'll have to hit the books for your make and model of storage. What I would recommend is the classic example when you're hitting towards 1 terabyte of data in one database. Now's the time to start looking at things like snapshot backups to be able to back them up within a matter of seconds. Even if you didn't buy features like snapshots or automated tiering in your storage today, get your make and model for storage to get their best practices to figure out how you should configure your databases to work with them, so that then you can say, well, to management, here's what it would take for me to implement backups within 30 seconds or automatically have our fastest data on the fastest tier.